Hello, in this video, we'll be solving the homework problems from Chapter 12. We'll be solving problems 1, 4, 8, 13, 21, 27, and 32. Let's begin. 12.1 says, on a part-time job, you are asked to bring a cylindrical iron rod of length 85 centimeters. Let's go ahead and convert that, 0.85 meters. And diameter 2.85 centimeters, 0.0285 centimeters. From a storage room to a machinist, will you need a cart? To answer, calculate the weight of the rod. We're going to be doing this by the density. We'll be using the density of iron. Rho equals 7.8 times 10 to the third kilograms per meter cubed. And it's a cylinder, so the volume of a cylinder equals the area, which is pi r squared, times the length, L. Okay, so the volume is going to equal to pi, and r was the radius or diameter, or that 85. Iron of length 85 and diameter 2.85. Okay, so diameter is going to be equal to half of that, so times 0.0285, that's meters, sorry, meters over 2, quantity squared, times length, 0.85 meters. And this is going to be 5.474 times 10 to the negative fourth meters cubed. And then we'll see how much it weighs. By finding the mass, and then, so mass equals rho v. Because rho, that's mass over volume, times v is going to give us mass. So we're going to have 7.8 times 10 to the third kg per meter cubed times 5.474 times 10 to the fourth meter cubed. And we're going to get 4.27 kg, 4.27 kg for the mass. And the weight is going to be that times 9.8 meters per second squared, which is going to be 41.8 newtons. Which, let's see, I don't know the conversion, but it's not that much. We weigh much more than that. Number 12.4 is a gold brick. You win, I like this one. You win the lottery and decide to impress your friends by exhibiting $1 million cube of gold. At the time, gold is selling for $1,282 per troy ounce. So $1,282 per troy ounce. I'm not sure what that is, but and 1 troy ounce weighs 31.035 grams. So that's going to be 1282 by 31.035 grams. Which is going to be 1282 over 0.031 let's just go with 0.4 kilograms. And how tall would your $1 million cube be? Okay, so the density of gold, rho, equals 19.3 times 10 to the third kg per meter cubed. We want to know how many meters cubed we have. So we're going to divide our, first we have to find out how $1 million. Okay, so we have to do that first. We have to find how many troy ounces in 1 million. All right, so we have 10 to the 6 dollars. This is a conversion problem. Times 0.03104 kg per $12.82 times 1 meter cubed times 19.3 times 10 to the third kg. All right, let me get out my calculator and do this one. So I'm getting 0.0012, let's go with 5 meters cubed, and then take the cube root of that. So to the power of 1/3, let's see how high it is. I'm getting 0.11 meter. So wow, $1 million of gold is not that big. 11 centimeters tall. $12.8 is black smokers. Says black smokers are hot volcanic vents that emit smoke deep in the ocean floor. Many of them teem with exotic creatures, and some biologists think that life on Earth may have begun around such vents. The vents range in depth from 1,500 meters to 3,200 meters below the surface. What is the gauge pressure of a 3,200 meter vent? Assuming the density of water, assuming the density of water does not vary, express your answer in pascals and atmospheres. Let's find the density of water and continue. Okay, so the density of seawater is rho of seawater is going to be 1.03 times 10 to the third kg per meter cubed. And the pressure below a column of water, P, is equal to rho GH. So we've got 1.03 times 10 to the third kilograms per meter cubed times 9.8 meters per second squared times 3,200 meters. And this is going to give us 3.23 times 10 to the 7th pascals. And converting that to atmospheres, 1 atmosphere is equal to 1.013 times 10 to the 5th pascals. And that's going to be equal to 319 ATM. Which is kind of a lot. 1213 is called standing on your head, and it says, what is the difference between the pressure of the blood in your brain when you stand on your head and the pressure when you stand on your feet? Assume that you are 1.85 meters tall. The density of blood is 1060 kilograms per meter cubed. And what effect does this increased pressure have on the blood vessels in your brain? All right. Solve this much like the other one. Pressure is going to be equal to rho GH. It's going to be equal to 1060 kilograms per meter cubed times 9.8 meters per second squared times H was 1.85 meters. And that's going to give us 1.92 times 10 to the 4th pascals. That is the increased pressure, which causes pressure in your blood vessels. 1221 reads, a cylindrical disc of wood weighing 45 newtons. And having a diameter of 30 centimeters. So 0.30 meters. This is weight. This is diameter. Floats on a cylinder of oil of density rho equals 0.850 grams per centimeter cubed. Oh, we're working in centimeters cubed. All right, so we'll go ahead and do this 30 centimeters. Oh, but we got newtons there. Okay, well, let's deal with this, cross that bridge when we come to it. The cylinder of oil is 75 centimeters deep and has a diameter the same as that of the wood. What is the gauge pressure at the top of the oil column? Suppose now someone puts a weight of 83 newtons on top of the wood, but no oil seeps around the edge of the wood. What is the change in pressure at the bottom of the oil and halfway down? Okay, the pressure underneath the wood is going to equal to the force, the weight of the wood divided by the area. So that's pressure is defined, P equals force over area. And in this case, it's weight over area. So we have 45 newtons. And it's a cylinder. So that's going to be 2 pi r, let's see, pi r squared, I'm sorry, pi r squared. So pi times r is 0.15 meters squared. And we're going to get 45 newtons divided by 0.0707. 0.0707 meters squared. So the pressure is going to be 636 pascals. Now let's see. Now what do we do? Now what is, suppose now that someone puts a weight of 83 newtons on top of the wood, but no oil seeps. What is the change in pressure? So by Pascal's law, the change in pressure is going to be transmitted equally throughout its enclosed fluid. So the change is going to be 83 newtons divided by 0.0707 meters squared. And that's going to be equal to 1170 pascals. 1227 reads, a 950 kilogram cylinder can buoy floats vertically in seawater. The diameter of the buoy is 0.900 meters. That's D. Calculate the additional distance the buoy will sink when an 80 kilogram man stands on top of it. So weight equals 80.0 kg, 80 kilogram. Okay. So now by Pascal's, no, Archimedes, force buoyant is going to be equal to the weight of the displaced fluid. And we know the rho of seawater from the other problem was 1030 kilograms per meter cubed. So if I add mass or weight to my buoy, it's going to sink an additional amount and displace an amount of a volume of seawater equal to the weight. So let's go ahead and do 80.0 kilograms divided by 1030 kilograms per meter cubed. And that's going to give me 0.07767 meters cubed. And now volume of a cylinder equals pi r squared L. So I want to know L. So 0.07767 meters cubed divided by pi, and R is going to be times 0.45 meters squared is going to give me L. And let's see, L is going to be equal to 0.122 meters. So that's how much it will sink. (1232) says a hollow plastic sphere is held below the surface of a freshwater lake by a cord anchored to the bottom of the lake. The sphere has a volume of 0.650 meters cubed. And the tension in the cord is T equals 1120 newtons. Calculate the buoyant force exerted by the water on the sphere. What is the mass of the sphere? If the cord breaks and the sphere rises to the surface, when the sphere comes to rest, what fraction of its volume will be submerged? All right, for the buoyant force is going to be equal to the weight of the displaced fluid. And for fresh water, rho is going to be equal to 1,000 kilograms per meter cubed. And we've got displaced a volume of 0.650 meters cubed times 1,000 kilograms per meter cubed. So my force buoyant is going to be equal to 650 kilograms. Oh, no, that's my mass. 6, 5, 1, 2, 3, yeah, 0 kilograms times 9.8 meters per second squared. So my force buoyant is going to be 1, 2, 1, 2, 3, 6, whatever this is. Let's see. 6370. 6370 newtons. All right, that's part A. Okay, now I'm supposed to calculate the, let's see. What is the mass of the sphere? All right, so we have the buoyant force wants to go up minus the mg, which is keeping it down, is going to equal to the tension. So we have supposed to calculate that. So T, let's see, plus mg equals B, but I want to, how about B minus T equals mg, and then how about B minus T over G equals M. So the buoyant force is 6,370 newtons minus 1120 newtons divided by 9.8 meters per second squared is going to give me M. So let's see, what is that? That's going to give me 536 kg. M equals 536 kilograms. Right, because the buoyant force is bringing it up, and then the tension is, or the weight is holding it down. So the tension's got to be equal to whatever that difference is. And then what else do I have to do? The cord breaks. When the sphere comes to rest, what fraction of its volume will be submerged? All right, by definition, force buoyant equals weight of the equals, it's floating, it's going to be weight of the object, mg. So that's going to be 536 kgs times 9.8 meters per second squared. That's going to be equal to, let me clear up some of the space. All right, calculators, clear. 536 times 9.8 equals 5,252.8 newtons. So that's the force buoyant, that's the weight of the object. And to find the volume, I shouldn't have done, well, let's find the volume. So 5,252.8 newtons divided by 9,800 newtons per meter cubed is going to be 0.536 meters cubed. 0.536 meters cubed. That's going to be the submerged. So what percent of the volume is that? So 0.536 meter cubed divided by 0.650 meter cubed. So divided by 0.650. 82%. Or 0.82. That's what that's out of 1. So 82%. Okay, and that concludes chapter 12.